Hello, everyone. Welcome back. This is a Calculus 3. So in this video, we are going to talk about 3.3 arc length and curvature. So in this section, we're going to learn and study a couple formulas related to curves in both 2 and 3 dimensions. And we will see how they are related to various properties of the curve in 3-dimensional space. So sounds a little bit abstract. So I'm going to show you, the previous concept that you learned about arc length in Calculus 2. So if you guys remember, let's recall. So do you remember the arc length formula from single variable in Calculus 2? So if you guys remember, in Calculus 2, we've been dealing with one variable. So let's say you have a function f of x looks like this, up and down curvy shape. And then I want to find out this length from A to B. So by using the integral, you can find out so many information, not only just area, volume, arc length, surface, and other physics concepts. So one of the benefit of using integral, yes, you can find out the arc length. So this is not the linear line, this is a curved line. So by taking integral from A to B, with the radical 1 plus, and take the derivative, dy over dx, and you're going to square of it. And then you can find out the length of this, curve between A and B. So that was the concept that you learned, how to find out the arc length formula in Calculus 2. So what we're going to do in here, we're going to do the similar thing, right? So we're going to do the similar thing. So let's go down slowly. So this concept developed too, same thing. What if we have a vector, right? So if you remember, we have a two curve. One is a plane curve. You are dealing with two components of the vector. And we have a space curve. You are dealing with the three components of the vector. So we know what plane curve look like. You have each point from x and y, and then you're going to collect all the points. They're going to create a curve. How would you be able to find out the length of this vector? You can take the derivative of each component, because if you remember plane curve, this is a vector valued function. Do you remember that? So our vector, if you look at the components, the component itself has a function format. So you can take the derivative of each function of the component and then square of it. And then from A to B, you can find out this length of the arc. Likewise, if you have a three, right, components, and then everything is a function format, same thing, you're going to take the derivative and square it, and then take the square root from A to B. You can find out the space curve from A to B. So that's the similar formula, right? We've been talking about in Calculus 2. So here you can find out the plane arc curve and space arc curve by using those two formula. If you have just the r vector, you can take the derivative, the magnitude of the vector, that also give you the plane curve length. So same thing, you can utilize it. So we are going to use this formula to find out the arc length of the vector function, okay? So this is the vector. You can find out the length of the vector. So let's take a look at the example. So let me go to the example. Here we go. So find the arc length of the vector function. So this is a vector value function, and each function here we have f, g, h. So we know what the formula are, so you can utilize either this one or that one, but the r vector is already given. So let me rewrite it. R vector is 2t squared plus 1 comma 2t squared minus 1 t to the third. I'm going to use this formula, right? So this is the same as the left and right. So r prime, you can take the derivative. So what would it be? This is going to be 4t, 4t, and 3t to the second power. And then you're gonna take the, magnitude, because we are looking for the magnitude of the r prime. So it would be 16t squared plus 16t squared plus 9t to the 4. So that's how you're finding the magnitude. So if I combining the like term, 32t to the square plus 9t to the 4. And then I can find out the common factor, which is t to the second, 32 plus 9t to the second. And then we know t to the second, this one is going to be simply t, because you can separate it. So this is going to be t, and 32 plus 9t to the second power. So that's just the r, right? Prime with the magnitude. Now we are looking for the length from where to where, from t 0 to 3. So now you're going to arc length of the vector from 0 to 3, which is that one, t radical 32 plus 9t to the second power dt. We are taking the integral with respect to t. So now what are you guys going to do? This is a little bit of integral technique. So let me minimize it. So what happened? I'm going to use the u substitution, because of 32 plus 9t to the second. So you're going to literally using the u substitution. Let u 32 plus 9t to the second du over dt. We're going to get 18t. Am I correct? So what happened? This means du equal to 18t times dt. If you remember calculus 2, you need to find out the, you need to convert whatever t variable in terms of u. So t dt, to find out what the t times dt, I'm going to divide it by 18, both of sides. So then we have, I'm going to move this one a little bit upper. So we're going to get du over 18 equal to cancel, t times dt. So let's plug in all the information. And then one thing you need to do, we also need to convert the interval 0 to 3, that's in terms of t. I want to convert it to the in terms of u. So u0, 32 plus 0, 32. u3, now 3 is going to be 32 plus 9 times 3 square. You should get big number 113. So this is a 32,113. So definitely we got it. So this information, integral from 32 to 113, we have a radical u, and then t times dt, that is 1 over 18 du. You are going to take the integral of that u variable. So let's continue. We are going to do this work. So I'm going to bring 1 over 18 to the front. So 1 over 18 from 32, 113, radical u du. So we can take the, integral. That means 1 over 18, 32, 113. Radical u means u to the 1 over 2 du. So 1 over 18, I'm going to take the integral. So what happened? U 1 over 2 plus 1 divided by that exponent from 32, 113. I can flip this one. So 1 over 18 times 2 over 3. U 3 over 2, 32 to 113. Then they're going to cancel. It's going to be 9 times 3, 1 over 27. U to the 3 over 2, 32 to 113. So let's finalize it. We're going to do capital F113 minus capital 32. So 1 over 27, 113 to the 3 over 2 minus 1 over 27, 32 to the 3 over 2. So this is a complicated, equation. So we're going to use a decimal. You can approximately. So I'm going to just go to decimal quickly. I haven't calculated. You can do calculated with me. So we have a 1 over 27 times 113 to the 3 over 2. And then we're going to subtract 1 over 27 times 32 to the 3 over 2. So they're going to calculate for you approximately 37.8. I just round up. So 37.8. Oopsie. 37 point. So yeah, we have it. We have a 37.8. This is the arc length of this particular vector. So they're going to create, vector. It's a curvy line because it's a vector valued function. So we just found out the length from 0 to 3, which is a 37.8. That's how you do it. How you feel? Does it make sense to you? So calculus 3, the concepts are not really difficult. It's pretty much similar what you learned from calculus 1 and 2. We are using the similar techniques such as integral and derivative. Just you're expanding the knowledge from one variable to two variable in three-dimensional space, okay? So keep in mind, so this is the formula to find out the arc length of the vector, especially vector valued function, whether you have a 2 components or 3 components. Got you? All right, so we're gonna go to the next concept. I'm not gonna do all the practices, but I'm gonna practice just couple example. So let's go to the next example. I have one more example. I'm gonna do the second example instead. The letter A, you can try. This is gonna be the 2 components. You can find out the the arc length of the vector of the 2 components. But I want to do the letter B, the 3 components one. Okay. So we know the formula, right, to find out the arc length of the vector. So we know from A to B, R prime T vector dt. That's what we're going to do. And in this time, we have 3 components of this vector valued function. So let's take a derivative to find out the R prime. So let's do R prime. Here, what happened is each function has a 2 variable, t times cosine t, t times sine t, and the 2t is just linear. But how would you be able to find out the R prime, right? So in this time, R prime, you take the derivative, but we are going to use the product rule, right? So what I'm saying is I'm gonna just write it, this one a little bit bottom. So here you have f is a t, g is a cosine t. So f prime will be 1, g prime will be negative sine t. So when you're taking the derivative, you're going to use the product rule, isn't it? So same thing here. F is a t, g is a sine t, f prime is 1, g prime will be cosine t. So we're going to use here product rule. So therefore, R prime, we are taking the derivative, right? And then f prime times g minus g prime f comma, another f prime g minus g prime. Actually, product rule is positive. You have to do this one. And 2t is going to be just 2. So by doing this work, what you're going to get, f prime 1 times g cosine t plus g prime negative sine t times f. This is the first function derivative. Second function, f prime 1 times cosine t, my bad, 1 times g sine t plus g prime cosine t times f. And then we have a 2. So this is R prime components when you take the derivative. Are we okay? So let me rewrite it. I need more space. So here, because we need to use this formula. So I need r prime. So therefore r, I'm going to change the color again. R derivative, we got cosine t minus t times sine t. I changed the order. And then 1 times sine t plus t times cosine t 2. This is r derivative. You took the derivative of it. And then we're going to find out the magnitude of it. So that would be all the way radical cosine t minus t sine t second power plus you're going to adding all the square. That's a square plus 4. So let's expand it. So if you expand cosine second t minus 2t cosine t times sine t plus t square sine second t. I just expand the first parenthesis and you're going to do the next one. Sine second t plus 2t sine t cosine t. I need to make a little bit smaller. And then plus cosine t square plus 4. So I just expand everything. And then what happened? Minus plus 2t. Bye-bye. They're going to be cancel. Plus minus 0. And I can combining cosine second t plus sine t. We know cosine second x plus sine second x is always 1. So you can rewrite it. What happened? Cosine second t plus sine second t. And another one here, I can combine this. T second. So let me double check. I have a sine second t. So I'm missing here cosine second t, and then I'm missing this one. We have a t second. So I'm going to combine this. T second sine second t plus t second cosine second t, correct? So these two combine. And then you found out this 2 is going to be 1. And we have plus 4. So this is going to be 1. And what happened? T second, I can combine it. Again, sine second t plus cosine second t, that's going to be 1 again. So we have all number. 1 plus, this is going to be 1 times t second plus 1, gotcha. T second plus 5. This is the magnitude of the r prime. Are we done? No, now you need to find out the arc length from 0 to 2 pi. So 0 to 2 pi, arc length of the vector, 0 to 2 pi. We just found out everything. So t squared plus 5 dt. So this is exactly magnitude of the r prime. Am I correct? So again, here you can use a u substitution, but a little bit of note. Check with integral table. So we are using integral technique, especially you have u squared plus a squared du. You remember this one is going to be u over 2. Go to the integral table. U squared plus a squared plus. There is a formula if you have this type of integral with the function a squared over 2 and then u plus, I need a space. And then u squared a squared in absolute value c. So if you take the integral u squared plus a squared with the radical, very similar form, the outcome is going to be this. So we're going to apply that. We're going to apply this one. So what happened? This answer, we get a, you see that u is a t. And then what happened? I see that a is going to be a squared is going to be 5, correct? So we can utilize it. U is a t over 2. U is a t squared, a squared 5, plus a squared 5 over 2 ln. Absolute value U is a t. So t squared plus 5 plus c, and then you're going to do from 0 to 2 pi. So that's what you're going to get. And then now you're going to plugging in, 2 pi over 2 pi second plus 5 over 2 ln, 2 pi plus 2 pi second plus 5. That's your answer. So now you're going to plug it into the decimal because the next one is a 0. You don't need to care. So that's whatever the answer. It's your arc length of that vector with 3 components. Does it make sense? So I will show you that work one more time. So letter B, we are doing the same thing. We are looking for the arc length of the vector valued function, especially when you have 3 components. So the formula is this, right? So the formula is this. So I took the derivative of r vector, we got it. And the magnitude of the derivative of the r vector, we got it. And then plugging into the integral to find out the length from a to b. So in this time is 0 to 2 pi. This here, I utilized the integral techniques. If you go to integral table, there's so many, possible formula you can utilize. So if you have that particular function, you can get that outcome. So I just substitute it, and then you can simplify that answer at the end. That's it. Okay. So that's how you're going to find out the arc length of the vector valued function. And then if you remember last video, I'm going to just talk about a couple things before I'm going to go to the arc length parameterization. So let me just go down slowly. So do you remember once you find out the, the vector value, if you graph of vector valued function, it could be, it's a little curvy line, but sometimes you have very like a spring, right? So my graph is not great. So sometimes you can find out the cylinder shape if you watch the video. So we call the graph, the line of the vector value function, we also call that as a parameterization equation. Do you remember that? So if you watch the video, please go back. I believe 3.2, the last part, we talked about it. You can convert, you can find out the, Cartesian equation to find out the shape, but also you can find out the vector valued function, because when you graph the vector value function, they're going to somehow create a shape. And that shape we have, cylinder or cone shape, things like that. So there's a way you can do, find out the parameter. This is a parameterization equation from the vector value function. And then if you just follow the parametric equation, they're going to create a shape such as a cylinder or a cone. So just take a look at 3.2. So there is a very similar concept. I'm talking about the same thing. Now we are doing the same thing. What is arc length? So basically this is same question. We are looking for the arc length of the vector value function. In this time, it's going to be more like a, curvy or twisted, but the formula is the same thing. You have an r vector, take the derivative and second power, or just take the magnitude of the r derivative from a to b. You can find out the arc length parameterization. Okay. So take a look at 3.2 video we just talked about in the last time, the last section of 3.2. There's information about how to, what that mean parameterization equation in terms of the vector value function. So basically, if you graph it, vector value function, they're going to be maybe create a cylinder. So cylinder has a specifically their own equation in terms of the Cartesian equation, rectangular, including x, y, z. But if you look at the vector value function, it is going to be in terms of the vector system, right? So that it's a very how do I can say if you just create, look at the graph, the vector value function, they are construct a kind of like shape, such as cylinder, such as a cone. So we call that particular, equation of the vector value function, we call parameterization. Okay. So let's take a look at the example. So it's the same thing, right? The formula is the same. Nothing is special. So the question is same, find out the arc length, vector value function, or parameterization. We know that they're going to create, a shape. So therefore, there's nothing we can, differently, do this problem. I'm gonna do, let's try letter B, okay? Because I wanna deal with more, 3 components. So we have a 3 component, let's find out the arc length. So R prime, it's a 1, 2, 2, right? Or let's take a look at A first, because I wanna just explain it more. Let's take a look at A first. Okay, because A looks more complicated. We have a cosine and sine. So I want to do more challenging one. So A, R prime T, right? What happened? You're going to, so this is the vector for cosine T, for sine T. So this is, I'm going to move this one here, and this is R vector. This is R, and then let's take a look at the derivative. So it's going to be cosine will be negative. So negative for sine T. Sine will be cosine T. And now you're going to take the magnitude. So it'll be 16 sine second T plus 16 cosine second T. So it is going to be 16 sine second T plus cosine second T. This is going to be 1, so radical 16 will be 4. So the arc, the magnitude of the arc derivative of the vector is going to be 4. Now we know the interval. So the arc length is going to be from 0 to t for dt. So that means 4t by taking the integral 0 to t. So we should get, this is going to be 4t minus 40. So it's going to be 4t. So what I got here, we are going to call this is the arc length. Let's say S, that arc length is a 4t. Okay. And I'm going to write a long statement, what that means. We know what that means, but here, I'm going to make a space here. Okay, so S equal to 4t, we know, gives the relationship between the arc length S and the parameter t as S equal to 4t. I'm gonna change this one in terms of t. We can solve for t. So it's the same as S divided by 4. We can replace. Then replace the t equal to S over 4 in the original R vector equation for cosine ti plus 4 sine tj, and then we're gonna substitute. So now if you substitute R t is going to be S over 4. So 4 cosine S over 4 I, 4 sine S over 4 j. By just plugging in. So what does it mean? This is going to be, this is the arc length parameterization of RT in terms of the T variable. And then since the original equation has a restriction on T with T is greater than 0. So the new equation of parameterization has, or no, the equation parameterization has less restriction to define both S and T. So we know we used to have, in the original equation, we used to have T equal to, so here we have T is greater than 0, but here we have S over 4 is greater than 0. This is better because we are talking about the arc length S over 4 greater than 0. So I'm not going to ask you this part, but I'm going to ask you find out the parameterization equation in terms of the arc length. So this is the answer you can actually talk about better. So one more time. So it's the same formula to find out the arc length, but I'm talking about the parameterization. So there's a couple like straight, because it could be curving, it could be twisted. It's not just, one curved line. So you're going to take a look at the, what the S, this is S. And then we found out S equal to 4T. We're going to solve for T because the parameterization is in terms of T. And then you're going to plug in back to the original equation. This is the parameter equation. This is the original equation. So that's what they mean. They're same meaning, but as you remember, parameterization is the graph of the vector value function, but particularly the parameterization, they're gonna create a shape such as a cylinder or helix, if you remember, or cone. If you are drawing the vector, they're creating the cone, or sometimes they're creating the cylinder, right? So I wanna distinguish between the regular vector function and parameterization. So therefore, parameterization is going to be in terms of S, which is the arc length. And the regular function is in terms of T. So you can think about the difference. So that's what they mean. Okay, so you can think about it. I'm gonna do one more example, letter B. As I promised, let's talk about the 3 components. So it's the same thing. I'm gonna change the color. How about that color? So we're gonna do letter B. So I'm gonna write that RT. So actually we're gonna need more space. So here, B, RT is, we have a T plus 3. The second question, minus 4 to T. So R prime, we have 1 to 2. And the magnitude, R prime T, will be 1 plus 4 plus 4, radical 9. Ooh, that is a 3. Okay, so now the S will be from where to where? T has a restriction begin from 3. So this is not really in terms of the R. T is greater than 3. So 3 to T. And 3 dt. So we have a 3T from 3T. So if you subtract 3T minus 3 times 3 is a 9. So this is S. So I'm going to write the same sentence. So S equal to 3T minus 9 shows the relationship between the arc length S and the parameter t. We're going to solve for t. So s equal to 3t minus t. We are going to solve for t. So adding 9 both of sides, s plus 9 equal to 3t. And we're going to divide it by 3. So s plus 9 over 3 equal to t. In other words, t equal to separated s over 3 plus 9 over 3, 3. So this is a t equation. We are going to sub t equal to s over 3 plus 3 into the original equation to find the equation of parameterization. So if we do that, rs, like that, rt used to be t plus 3 2t minus 4 2t. Now rt is going to be s over 3 plus 3. It's the same equation, just in terms of s, in terms of the arc length. So it is going to be s over 3 plus the 3 plus 3. 2 times s over 3 plus 3 minus 4. There's a comma. And then 2 times s over 3 plus the 3. So therefore, simplify s over 3 plus 6, comma, 2s over 3, 6 minus 4, 2s over 3 plus 2 over 3. Again, it is going to be s over 3 plus 6, 2s over 3 plus 2, 2s over 3 plus 2 over 3. So that's the parameterization vector. And you can convert it to ijk. You can find out equation. So this is the arc length parameterization of rs. Okay, the original restriction on the t is greater than 3. Now you have a better. So original equation has a restriction t is greater than 3. Now s, this is s over 3 plus the 3 is greater than 3. So this is in terms of the s. Okay, so that's how you are going to explain the parameterization equation in terms of s. Okay, so that's something I want to talk about it. Okay, I'm gonna keep going because we have a lot of things to talk about it. I know, so let's go. So I'm not gonna do this one, try yourself. So I show you a Volvo example, you can do that, okay? Now I'm gonna introduce the last concept, curvature. So far, we talked about, you can pause the video, we just talked about how to find out the arc length of the vector with the 2 components or 3 components, and also how to find out the parameterization equation in terms of the arc length as well. Now we're going to talk about curvature. So curvature, that's a definite. Curvature is the magnitude of the rate of change of the unit vector with the respect to arc length. So whoa, what is that? So in other words, curvature is a smooth curve at a point, a particular point, and it is a measure of how quickly the curve changes direction at the point. So let's say I have a vector. It's a very interesting vector. You have up and curve, up and curve. And then when you look at the tangent line, tangent vector, you can find out infinite tangent vector. So here's a tangent vector, here's a tangent vector, tangent vector. So by looking at the tangent vector, they're quickly changing the direction of the tangent vector, right? So we are measuring the ratio, we are measuring the rate of change of the tangent vector. What is a tangent vector? You're touching one point. You're touching one point. They keep changing because this curve is a curvy shape. It's not the linear. So we are measuring the rate of change of the unit vector. That's what we call curvature. okay? And I'm gonna introduce 3 ways to find out the curvature because we wanna find out the magnitude, how they fast change the direction in terms of the tangent vector when you have a given like a vector line. So here is a 3 equation. I'm gonna highlight it. One is when you can find out the tangent vector, the K represent curvature, and then T prime divided by R prime with the magnitude, or depending on the given information, you're going to use one of the equation, or double prime divided by the third cubic, or if you have equation, you're going to use the last one. So I'm going to show you each case. 1, 2, 3. Keep in mind, we're going to calculate the magnitude of the rate of change, how fast, how quickly they're changing the direction of the tangent vector in terms of the vector arc length. So there are 3 equations I have here, same thing. So let's step-by-step work. I will show you each question, which one is going to use the first, the second, third formula. They're same, they're going to find out the same answer, but depending on the given information, you're going to use one of them. So let's do example 5. Find the curvature. You see that? We are going to find out the curvature, the magnitude of the rate of change of the unit tangent vector. So we have a letter A. Let's write down in terms of the vector form. So R is going to be 4 cosine t, 4 sine t, 3t. And then since we have R vector is a given, right? You can use the first formula, right? Because R vector is a given, then you can use the first formula to find out the curvature. So let's take a look at the R prime. So that's a 4, it's gonna be negative 4 sine t, 4 cosine t, 3. And the magnitude R prime t, 16 sine second t, 16 cosine second t plus 9. I see the combining 16. So sine second t plus cosine second t plus 9. This is going to be 1. So we have 16 plus 9. That would be 25. We got 5. This is the magnitude, our derivative. And now what do you know? We know how to find out the t. So if you forgot the unit vector, here's the formula. You can find out the unit vector. I'm going to write it here. So note t, the unit vector, if you watch the previous one, this is a tangent unit vector. The formula t will be calculated R prime t divided by magnitude of the R prime t. So remember, this is a unit tangent vector. So therefore t here equal to, we have R prime divided by 5. So 4 sine t, 4 cosine t, 3 divided by 5. So what happened? I'm going to separate them. So it is going to be t negative 4 sine t over 5, comma, 4 cosine t over 5, comma, 3 over 5. And then t prime, because that's actually what we need to find out the k. So that's a t unit vector. So what I'm going to do here, we are looking for curvature. K equal to the formula t prime divided by R prime and magnitude, or you can separate them. So anyway, if we do it, t prime, we can also need to find out the t prime of negative 4 over 5, sine will be cosine, and negative 4 over 5 sine t, 3 over 5 will be 0. So this is a t prime. And we already know what the R prime. So K will be T. We have to put the magnitude. So this is going to be the magnitude T. So this is going to be 16 over 25 cosine secant T. 16 over 25 sine secant T divided by 5. So this is T prime. And then this is R prime magnitude. Are we okay? So if you calculate it, the numerator is 16 over 25 cosine secant T sine secant. That's going to be 1. So 16 over 25 over 5. So if you simplify, this is a 4 over 5 divided by 5. It's going to be 4 over 25. This is the curvature. This is the magnitude, you know, about magnitude of the rate of change of the unit vector. So that's how you got letter A, curvature. We used the first formula. So there's a couple things you should know how to find out the unit tangent vector and each step, da 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 da. Now I'm gonna do the letter B. Okay, you can think about it. Depending on the given equation, you're gonna use one of the formula to find out the curvature. We know what that means. So let's take a look at B. This is what? What is going on? This is not the vector form. You see that? This is the equation. We have an equation. So if the function is a given equation, you're going to use the third formula. You see that? So given the information, if you have a vector given, you can use either first and second equation. But if you have a given function, you're going to use a third method. So this is the given function. So therefore, we're going to do that work. So the B, f of x equal to 4x minus x. This is not vector function. This is actually a semicircle equation. So if you draw this one, something they're going to create that shape. They want to find out this arc length. And they want to find out how quickly the unit tangent vector changing. They want to find out that ratio. So according to the third formula, I'm going to write it and then you don't need to be confused. So we're going to find out curvature by using the third method. This one over, you need to find out the double derivative 1 plus y prime second magnitude 3 over 2. So we're going to do step-by-step work. So first, y is 4x minus x second. Radical is 1 over 2. I can take the 1 derivative. So 1 over 2, 4x minus x second, and 1 over 2 minus 1. And you have a chain rule, which is 4 minus 2x. Am I correct? And now we are going to find out, I'm going to rewrite it, 1 over 2, 4x minus x second, negative 1 over 2, 4 minus 2x. You can simplify the 4 minus 2x. There's a common factor 2, so I can rewrite it. 2 minus x, so 2 cancel. So y prime is a 4x minus x second, negative 1 over 2, 2 minus x. Okay, good. I want to find out the y prime. Take the derivative one more time. But in this time, what happened? F and G, product rule. So y prime is going to be f prime G, G prime F. So let's find out what the F is for X. If you feel confused, I'm going to change that order because that's going to be better. So what I'm saying is I'm going to find out the y prime before we're going to define F and G. Let's change the order. 2 minus x first, 4x minus x second to the negative 1 over 2. So this is F and G. So F is, we know, f is a 2 minus x. F prime will be -1. G is a 4x minus x second. -1/2. G prime, what are you going to get? -1/2. 4x second. -1/2 minus 1. Chain rule 4 minus 2x. Again, -1/2. 4x minus x second. And we have a 3/2. That's -1/2 minus 1. I can factor 2. 2 minus x. 2 cancel. So -4x minus x second. -3/2. 2 minus x is y prime. Are you following? So little bit. So this is a g prime. Sorry, this is a g prime. Now let's find out the y double prime. Now I'm going to use the product rule. So watch me. This is y. This is y prime. We're going to calculate the y double prime using the product rule. So let's do the work. We have a y prime. F prime is a -1 times g for x minus x second, -1/2. Plus the g prime, we have a -4x x second, -3/2, 2 minus x. This is a g prime times f, 2 minus x. Awesome. So now let's simplify. I'm gonna do -4x, right? So 4x minus x second, -1/2. And then I'm going to put the negative because of the negative here. So negative, they're going to be second power. -4x minus x second to the -3/2 times 2 minus x to the second power. Are we okay? So this is the y double prime. I know you don't want to see the negative exponent, so you can change the negative exponent to the positive. So if you want to do that work, what happened? This is going to be same. So this is going to be -4x minus x second, 1, and then 4x minus x second. We have a 3/2. So why am I doing this? You remember that we have a negative x. It's the same as 1/ax. Because 1 minus this is going to be -1/2. So I just change it to the positive exponent. Minus, same thing. We have a 2 minus x to the second is in the top. And then this one is going to be in the bottom. So that I can have same denominator. Okay. So now they have the same common denominator by converting like that. So what can we do? Now I can combine it. The denominator equal 4x minus x second to the 3/2. You can expand it, -4x plus x second minus 4x plus x second. So what happened is we should get 4x minus x second to the 3/2. -4x minus positive 4x will be 0. X second minus x second, they're cancel. So we have only -4 remaining. So this is finally, this is your y double prime. This is your y double prime. So now what are you going to do? We have the formula k. Where are you? This one. This one, k. So this is your k. So we have a y. So absolute value, -4. 4x minus x second to the 3/2. 1 plus y prime we got. Where are you? Right there. So we have, I'm going to just bring this number. 1 plus 2 minus x. Let me just copy this. Y prime. Copy. So y prime here. So I'm going to get rid of this box. This is y prime. And then second power outside 3/2. Woohoo! Okay. So these three exponent, you can simplify. Before we're going to do, you can cancel -2 and +2. So this is going to be -4x minus x second to the 3/2 absolute value over 1 plus 2 minus x4 x, and then you multiply 2 here and here, so second power x minus x second, we have a -1 to the 3/2. So now you can plugging in this very ugly equation into decimal. So you're going to enter this 1 divided by that. As much as you simplify, you should get about 1/2. So this is a curvature of that particular function, semicircle. So you see that the calculation is a little bit too much, but that's how you're going to find out the curvature. Depending on the given information, you will find out, the curvature. Does it make sense? So think about it. That's what it is. And I'm showing you 3 different methods. So the first one, we use the first method. Second one, since the function was not the vector function, so we use the third formula with the given function. So there was a little bit of hard time to find out y prime, y double prime, but it might be good practice to do that work, okay? And then the last part, you can use a decimal to simplify as well, okay? One more example. Okay, one more example. I'm not going to do everything, don't worry. So here I'm showing you 3 different methods, as you know. Depending on the information, you're going to use either, right, the first one or a second equation or third equation to find out the curvature. Let's look at example 6. Find the curvature and then the twisted cubic. So this is the vector that they give us. This is going to be at 0, 0, 0. So whoa, 1 second. So cubic means it's a 3-dimensional curve. So definitely they're talking about the second method. And then the formula is going to be that. So we're going to do step-by-step work. The formula, let's take a look at RT is a t second, t to the third, r prime t, 1, 2t, 3t second. Let's do one more double prime. Thank you. This is a 0 to 60. And then according to the formula to find out the curvature, you have to do the cross product between r prime and r double prime and magnitude divided by r prime magnitude with the third power. So let's do the numerator. So r prime t times r double prime t. This is cross product. We know how to do the cross product. Do you remember? Make the matrix. So this is going to be I, J, K. So r prime 1, 2t, 3t second. R double prime 0 to 60. So we know by using the determinant, correct? So you can find out the cross product. So cross product I times, you do multiply those to 12t square minus 60 second. And then minus j, you have this one. So now you have those 4. So 60 minus 0. And then last one, k, we have here. And then you have 2 minus 0. So therefore, this is a 60 second I minus 60j plus 2k, which means this is your cross product. Now what happened? We have to find out the magnitude of it. That's a numerator. So the magnitude r prime t times r double prime we just got. So this is going to be 60 second negative 62. The magnitude 3060 to the 4, 3060 second plus 4. Am I correct? You can find out the common factor everywhere, 4 9t to the 4, 9t to the second plus 1, correct? And then 4 with the radical become 2 if you simplify. So we have 9 for 9t to the 4, 9t to the second plus 1. So this is your numerator magnitude. Now let's work on the denominator, which is a r prime. We have it, and the magnitude and third power. So r prime t magnitude to the third. So what is the r prime? We have it, which is a 1. So it's a here. So I'm gonna do magnitude 1 plus 4t second plus 9t to the 4 and to the third power. Am I correct? So you're gonna do that. So that's what it is. And then let's rewrite it. K. K is 2 radical 2t to the 4. I'm sorry, 9t to the second plus 1. And then you are going to 1 plus 4t to the second, 9t to the 4 to the third power. And then what happened? This is the K curvature, but they say when 0, 0, 0, that means t equal to 0. So they want you to calculate, find out the magnitude of the rate of the change of the tangent vector when t equal to 0, plugging in t, plugging in 0 into t. So the K, so this is going to be 0, 0. We have a 1. And the bottom, we have 1 plus 0 plus 0 to the third. 2 radical 1, gotcha, we have a 2. So this is the curvature when t equal to 0. So this one, we use a second method because it is a 3-dimensional space, cubic. And then be careful with the cross product. You know how to do it. So I show you all 3 methods, okay? So that's the curvature example. Are you guys okay with that? So this video will be a little bit longer than expected, so you can think about it. So this is all about curvature problem. So you can try yourself. So remember, I show you all the 3. All right, I'm gonna go to the next concept, okay? Here we go. So there's a couple, the vector system. So we are not just talking about the vector value or, parameterization. So here, I'm gonna introduce 3 important vector. We're gonna introduce tangent, unit tangent vector. We already know what that is. Unit vector and binomial vector. This is something new. So let's take a look at what they are. So here, the definition, I'm gonna highlight it. Unit vector, we already know the formula. So let's say you have a vector line. This is a vector. And then tangent vector, you are literally touching at this moment and the straight line. This is a unit tangent vector. So the formula was this. You're gonna take the r prime divided by its magnitude. So this is a unit tangent vector we've been talking about so many times. What is a unit normal vector? Unit normal vector is a perpendicular to the tangent vector, orthogonal to the unit tangent vector. So in the image, where are you? The unit normal vector. So you have the straight line, there is a creating 90. So this is going to be the perpendicular to the unit tangent vector. We call this is a normal vector, and the formula is going to be here. So if you want to find out the normal vector, you're going to take the derivative of the tangent vector and divide it by its magnitude. Same thing. The last one, binomial vector. So binomial vector means this is the unique last vector. So this is also perpendicular to both unit tangent and unit normal vector. So they're creating all 90 degree. Okay, so once you find out the unit tangent vector, you can find out the normal unit vector because they're perpendicular. Then also you can talk about the binomial vector because this is both perpendicular to unit and normal. So this is the formula. Binomial vector will be find out t unit vector cross product and the normal vector. So I will show you how to find out those 3 different unit vectors in the next example. So let's quickly go to there. So this is exactly what I want to do. Find out the tangent, unit normal, and binormal, 3 vectors. So if you remember, unit vector formula, T equal to R prime. You always begin from the given R vector so that you can find out the unit tangent vector. Unit normal vector, once you have unit tangent vector, take the derivative of the unit tangent vector, its magnitude. The last one, binormal vector, is going to be T unit vector cross product, normal unit vector. So remember, those are 3 equations. We just talked about it. So step 1, let's do step 1. Let's find out the tangent vector. So we have RT cosine T sine TT. R prime T, what happened? Negative sine T cosine T1. Okay, so therefore, what happened? The magnitude R prime T sine second T plus cosine second T plus 1. We know this guy is going to be 1 plus 1, radical 2. So this is the T. So now we can find out the tangent vector, R prime T divided by magnitude R prime T. So that's going to be negative sine T over radical 2, comma, cosine T over radical 2, comma, 1 over radical 2. Are you following? So we found out the tangent unit vector. Now what can you do? You can find out the normal unit vector. So I'm going to change the color. So normal unit vector, we're going to find out T prime first. So since we already know what the tangent vector, so from here, T prime is going to be what happened? T prime, so negative 1 over radical 2, sine T will be cosine T. And then we have a 1 over radical 2, cosine T will be negative sine T. And the last one is a 0. So this is a T prime. And then you can find out the magnitude. So if you calculate that, what happened? It's going to be 1 over 2 cosine second T, 1 over 2 sine second T, correct? So this is going to be 1 over 2 cosine second T plus sine second T, which is a 1 over 2 radical. It's going to be 1, so therefore 1 over radical 2. So we found out all the information to find out the unit vector. Normal unit vector was T prime divided by magnitude of the T. So therefore, you can say what happened? Negative 1 over 2. I'm going to just copy this. This one divided by this one divided by 1 over radical 2. So let me simplify this one. If you just divide it by each one, so basically this is going to be negative cosine T, because top and bottom cancel. Negative sine T and 0. So this is normal unit vector. You got it. Now we can find out the last one. The binormal vector set tangent vector times normal unit vector. So this is, be careful. That means cross product. So we have to do IJK. And then we know T right there. So I'm going to just make the highlighted. So T, we found out the tangent vector. We found out the normal vector. So we're going to plugging in there. Negative sine T divided by radical 2. Cosine T divided by radical 2, 1 over radical 2. And then the normal cosine T, negative sine T, 0. All right, we got this. So now we know by using the determinant, we can find out that. So what happened? you're going to do cross multiplication. That's 0 minus 1 over radical 2 times negative sine t. And then minus the j. The j is here. And then what happened? We have a 0 minus 1 over radical 2 times negative cosine t. And then last one, k. You have the last one. Oh, that's a little bit long. So negative negative is a positive. So you can actually minimize it so that I can write all the information. So negative sine t times negative sine t over radical 2 and minus cosine t times cosine t over radical 2. So this is the last part. Okay, let's simplify. So I double negative. So sine t over radical 2. Okay, minus j cosine t over radical 2. And then k, this is going to be sine square t over radical 2 plus cosine second t over radical 2. And then we know these two are going to be 1. So I sine t over radical 2 and minus, I can change that order, I in the back, minus cosine t over radical 2j. And then this is 1 over radical 2k. So now your binomial vector, gotcha. Sine t over radical 2 minus cosine t over radical 2, 1 over radical 2. That's the binomial vector. So we have all the information 3. So we found out the tangent unit vector, normal unit vector. So we know all the relationship, they're perpendicular to each other. All right, so we talked about this one briefly. I'm gonna just do one last example. Are you ready, ready? Here we go. I'm gonna do letter B. So I think you can do this question. Uh-oh, not the delete. I'm going to add page. So here, let's do letter B. Same question, we're gonna find out the unit normal vector and then find out the binomial vector as well. So let's take a look at those two. Or if you find out the tangent vector, that's great. Actually, we start from there. So let's do letter B, okay? Or I'm gonna change my mind. Let's do letter A because this is a number, but I wanted to complicate one, trigonometry. So let's look at it. RT, that vector, 4 cosine t, negative 4 sine t, correct? Now you can find out the prime, negative 4 sine t. You're taking the derivative, negative 4 cosine t. The magnitude of it, it's gonna be 16 sine second t plus 16 cosine second t. So these are gonna be 1 radical 16 because you are going to combine it, right? 16 times 1 is gonna be 16. So we have a 4. So that's the R magnitude. So therefore, tangent vector R prime divided by its magnitude. So we have everything. What happened? Negative 4 sine t divided by 4, negative 4 cosine t divided by 4. So therefore, 4 cancel, negative sine t, negative cosine t. So that's a unit tangent vector. I can find out the normal vector because it is going to be t prime divided by its magnitude. So we know from here, we got the t tangent prime will be negative this one. You're going to take the derivative. So that would be negative cosine t, negative, negative. It's a positive because a cosine is going to be negative sine. So positive sine t. So you found out that you're taking the derivative. So now the magnitude of it, we can also find out. The magnitude will be cosine second t plus sine second t. It's going to be 1. So normal unit vector, what happened? It's going to be this one divided by that. So negative cosine t sine t. Am I correct? Now you can find out the binomial vector, which is a cross product t times the unit vector times normal unit vector. So here, I just want to emphasize on something. Can we do the cross product? This is a cross product. So this is something you should know. Cross product only works for 3 components of the vector. So here, what happened? We have only 2 components. So it's not going to work. We cannot find out the 3 by 3 matrix. We can show, so can we show t times the normal unit tangent vector times unit normal vector? We cannot prove it. This one, sorry, B, we cannot show this. We cannot prove it. Thus, in this question, binomial unit vector does not exist because we cannot do the cross product. Only works for 3. So simply, maybe you can check. Simply, we can check it by dot product. Dot product works for 2 components. Dot product, right? So remember, BT does not exist, but let's try to the dot product. This is a 2 component dot product for 2 components. So we have T is negative sine T, negative cosine T dot. We have a negative cosine T sine T. So we know how to do the dot product, multiply and adding them. So sine T cosine T plus negative cosine T times sine T. What happened? They're going to be 0. So what does it mean? It shows us T normal unit vector and, tangent unit vector and normal vector are orthogonal, still orthogonal, even though we cannot find out the binomial unit vector, but still we prove that they're 0 means orthogonal perpendicular. So we have X, we have the vector is going here. So you have tangent vector, you have a tangent vector, you have a normal vector. So they're still orthogonal, but there's no binomial vector in this question. Okay, so you can think about this letter A. So now letter B, you can try yourself. There's a 3 components, so the binomial vector will be existed. All right, almost done. Hang in there. Hang in there. I got you. Finally, so 3.3 is a little bit challenging topic because we have a lot of information, but I want to finish. So last one, I just want to talk about quickly osculating circle. So I'm going to show you very simple definition. So if you have a unit vector and then binomial vector, okay, if they are perpendicular relationship. So we have, let's say this is the unit normal vector, and let's say this is going to be the binomial vector. And then we know that if they're perpendicular, they're going to be created circle shape. So for example, you have a function, you have a vector going and on. Here is the circle. Here is the circle. Here is the circle. because this is the moment where the unit normal vector and binomial vector, unit vector, binomial vector, unit vector, binomial vector, they're always perpendicular relationship. So we call this a circle is the obsculating circle. So that's the definition. And then once you find out the circle equation, you can also measure the radius. So let me show you that example. It's a very, very simple topic. So let's take a look at it. So here is the thing. We know everything how to find out the curvature. We know how to find out the equation. So here I have an equation of this obsculating. So there's obsculating. There's a circle. This is where binomial and either unit normal and binomial is going to be perpendicular. And then this function is a given y equal to 2 sine x. Okay. So step-by-step work. Let's find out the curvature. Okay, so this is the curved line. And then here you have tangent changing. So we want to measure the curvature first. So curvature, in this case, you have a 3 method, but this is a function given. This is not vector function, as you see. This is the function. So therefore, we are using the third method. Do you remember that? K equal to y prime divided by 1 plus y prime to the second power, and then magnitude 3 over 2. So we're going to do that work. Y is a 2 times sine x. Y prime, what are you going to get? Y prime is a 2 cosine x. So we want to know when x equal to pi over 2. So I can measure y prime 2 cosine pi over 2. So calculate it, it is going to be 0. And then this is the relationship. Let's take a look at the double prime. So 2 cosine x is going to be negative 2 sine x. And then y prime when pi over 2, negative 2 sine pi over 2. This is going to be negative 2. So what happened is we have everything. So therefore we want to know K curvature where pi over 2. So we have y prime pi over 2 divided by, and then we have 1 plus y pi over 2 prime to the second power 3 over 2. So we have everything. What is a y double prime when pi over 2? So this is the negative 2. And then we have absolute value negative 2 over 1 plus y prime pi over 2. We already have it. Y prime 1 over 2. So I'm going to copy this one. This is y prime pi over 2. That was a 0. So 0 to the second power 3 over 2. So what happened? 2 over, this is going to be 1, isn't it? So we got curvature at pi over 2 is 2. So I want to find out the equation, right? This is the equation. So we can also find out the radius of the osculating, the inside, like a, here under the, curve, that's osculating circle. Radius is going to be, if you remember the formula right there, 1 over k, which is 1 over 2. Okay, so you can have a radius 1 over 2. And then we found out the curvature at pi over 2 is 2. So what does it mean? So in this case, we have radius is a pi over 2. And then pi over 2, that you can find out the equation of the circle. So we have, I'm going to write it, x minus x0 square, y minus y0 square, it's r square. So you can find out, we have y equal to 2 sine x. So if x equal to pi over 2, what is y? It is going to be 3 over 2. So calculate it. So therefore the circle equation will be x minus pi over 2 second power plus y minus 3 over 2 second power, 1 over 4, center at pi over 2 and 3 over 2, radius is 1 over 2. Sorry, I talked too much today, but I think this is just the last question, how to find out the obsculating circle equation from the curvature, because they're going to help us to find out the radius. Okay, so that was the last concept. I just want to emphasize on one more time in 3.3. So 3.3, okay, let me just go all the way up. It was a lot. So we talked about how to find out the arc length of 2 and 3 components. And we also talk about a couple information, how to find out the tangent normal binomial. And last one was obsculating circle equation. So then you can finish all the 3.3 quiz, and feel free to email me if you have any question and join the discussion board, and then you can learn more and more. Okay, I will stop recording at this moment. I will see you guys in the next video. Thank you, everyone. Bye-bye.